Alright, so in today's video for Year 12 HSC PDHPE option for improving performance, we're covering our last dot point, which is the use of technology. So on the left-hand side of the syllabus, today we're going to go through two things, being training innovations, e.g. lactate threshold testing, biomechanical analysis, and equipment advances, e.g. swimsuits and golf balls. Alright. How you apply that information on the right-hand side of the syllabus. We need to describe how technology has been used to improve performance, but also argue ethical issues related to technology use in sport, such as, has technology gone too far, and has access to technology created unfair competition? Let's do it. All right. So the first dash we're looking at are training innovations, okay? So training innovations, which is basically new ways to train or new ways to analyze information from training to then use it, okay? So training innovations provide valuable information to athletes and coaches, allowing the training sessions to be manipulated to maximize physiological adaptations. That's the important part, okay? So it's not like they're coming up with new ways to do bicep curls, for example, but what they're doing is they're able to analyze movements, patterns, and the adaptations and the physiological responses that are happening during that training session, put that all into a computer, have a look at the data and go, okay, if we just tweak this slightly, we tweak this slightly, we can make it harder and therefore make it better for the athlete to improve their adaptations and therefore improving their performance, okay? So innovations include computer programs and software, such as, analyzing statistics, data, etc. Training facilities, okay, like special pools, special training surfaces, etc. And video analysis. And the video analysis component is usually used alongside the computer programs and stuff, so they use both to have a look at what the athlete's doing, how they're doing it, and what they can modify. So the two examples the syllabus tells us to go through are lactate threshold testing and biomechanical analysis. So I'll rub this off and we'll do it on both sides. All right, so our two training innovations are biomechanical analysis, lactate threshold testing. So we'll go through biomechanical analysis first. Biomechanical analysis involves filming performances and evaluating movements, techniques, and statistics, okay? It is strengthened by the use of full body sensors. So you may have seen pictures or videos of athletes and they're wearing basically these full suits and they've got little black dots all over them, okay? And it's basically analyzing all of their movement as they perform their sport. From that information, coaches can then identify strengths and weaknesses within the athlete's performances. They can correct movement patterns and techniques if they're not quite efficient, and therefore improve future performances. All right, so it's very valuable, very important information to have if you have access to it. The other one is lactate threshold testing. Okay, so if you remember back from your energy systems, you should know the word lactate should come to mind. Because you have your lactic acid system, all right, which is an anaerobic energy system. So fatigue from lactate accumulation is a strong indicator of aerobic performance, all right? So when you're working aerobically, you shouldn't be accumulating lactate. So why is this important, all right? Well, we know that lactate builds up when we work anaerobically, okay? So knowing how hard and how fast an athlete can continually perform in their aerobic zone is highly valuable, all right? So if you remember, you've got your training thresholds, okay? So cast your mind back. You've got an aerobic training threshold and you've got an anaerobic training threshold. Now remember, if you're above the aerobic training threshold, you'll make aerobic gains. And then if you hit the anaerobic training threshold, you make anaerobic gains and you stop making aerobic gains. Now, we roughly noted at somewhere between 80 and 90% of your maximum heart rate, okay? But that's guesswork. Lactate threshold testing, however, tells you specifically that athlete how hard they can work before they start accumulating lactate, which means that they are at the very, very top of their aerobic zone, which means they are making the most adaptations aerobically that they can. Hence, very important and very valuable information. So when coaches know this point, okay, they can modify training sessions so that athletes can maximize their aerobic gains, all right? Makes sense. Now this is done a couple of ways. The first way is done via blood sampling. Now this is obviously time consuming. It means you've got to stop the athlete working, draw blood out of them, analyze the blood, okay, it's a long process, it's an expensive process. Or more recently, we have wearable lactate analyzers, okay, which are basically, from my understanding, is that you sort of wear it like a watch, but it will analyze blood samples from you. So it just gives you like a little prick, analyzes the blood on you, sends that information off to the coach, and they can monitor that consistently as you perform, all right? Now, obviously, that type of technology, very, very expensive, all right? Which brings us to our point of ethics. So ethically, both methods are hindered by availability, all right? Teams with greater funding will always be able to afford more, when the athlete from a less fortunate team may actually be naturally better, but they just can't win because they don't have this stuff, all right? So imagine you've got two athletes, all right? Let's make them twins, but they were separated at birth, okay? So genetically they're the same, identical twins. So genetically they're the same, they have the same ability and whatever, all right? This guy goes to train with, you know, someone expensive, USA, Russia, China, etc. And this guy goes to train with someone less fortunate. I don't know, pick some small European country, all right? So ideally, in the competition, these two should equal if everything else was equal here, okay? But because this guy has access to training innovations, such as biomechanical analysis and lactate threshold testing, they're able to maximize their training sessions and therefore get greater performance and greater improvements, as opposed to this guy who genetically is the same, but doesn't have access to this stuff. So they just sort of, they hit like a ceiling as to how high they can perform, whereas this guy will obviously get more information and therefore be able to perform better. Yeah, so that's the point of ethics, and that's our training innovations. We'll now move on to our equipment advances. All right, so equipment advances is our next one we're looking at, all right? So equipment advances, and it should go without saying, have significantly improved performance for athletes over the years, all right? So compare like athletes, not only now to like 100 years ago, but now to 10 years ago, all right? A lot of the times, most of the time when you watch the Olympics, world records are getting broken. It's not because the athlete genetically is any different, all right? We're still basically the same people. But through our better ways of training, e.g. training innovations, and through the different equipment that we now use, it makes us better, all right? I'm not taking away from athletes, by the way. You still need to be the absolute top athlete to break those world records. But this stuff definitely helps. So common ways which this has been done by, number one, reducing times, all right? So for example, shoes that promote forward movement, all right? So like, you know, like Adidas Ultra Boost, like I know that they're just a very generic shoe. You obviously get very, very expensive versions of those if you're an elite athlete. But those shoes basically store kinetic energy. So when you step on the ground, it sort of, you know, boing, promotes you to go forward, all right? That obviously promotes movement efficiency. It means that you don't need to be putting in as much effort to move forward, and therefore that type of stuff has improved performance, all right? Number two, improved distances. Okay, so for example, golf clubs made from graphite and titanium as opposed to like the old, fiberglass and wood, all right? So graphite titanium has a lot more whip in it as it comes through, but also it's stronger. So as the club makes contact with the ball, that whip that happens obviously hits, like the contact speed of the club head and the ball is much faster, and therefore transfer of momentum, the ball goes further. Number three, improved consistency, all right? So looking at golf clubs again, golf club heads that are obviously larger, all right? And they're made from different materials, and they therefore reduce hooks and like accidental hook and slice. So if you ever play golf before and you hit the ball and it pings off to the left or pings off to the right and like just goes over the road and, you know, hit the old lady's house because you've just got a bad slice. Well, golf clubs these days, expensive ones, you've actually got to try hard to do that, all right? So they greatly improve consistency, which has an issue in itself, but we'll talk about that in a minute. So other types, and I've got a big list here in your class notes, but other types of equipment advances include clothing, so e.g. the type of material that's used. Swimsuits are a common one, which we're going to go through in a minute. Clothing that improves aerodynamics, shoes, etc. So you've got protective equipment, such as tackle suits and bags, protective headgear, mouth guards, shin pads, shoulder pads, etc., etc. We've also got equipment modifications such as in cycling, surfing, sailing, cricket and tennis, heart rate monitors and biofeedback, so wearable devices, all right? And lactate threshold testing is one of the ones that goes with. And rehabilitation equipment such as artificial joints, ligaments and tendons, ultrasound, laser, but also on a much smaller scale like skins, okay, would fall into a rehab equipment thing. Yeah, so here is a major issue. It's not an issue, it's a good thing, but it's also a bad thing, all right, which I'll talk about in a minute. But due to equipment advances, it makes sport safer, which is good, but it makes sport easier to participate in due to easier skill execution, all right? And I'll touch on this when I address golf balls in a minute. But in a nutshell, basically 10 years ago, the only world-class golfers were, not 10 years ago, 20 years ago, the only world-class golfers were ones that were actually good at golf all the time. But these days, because of all this equipment advances, it has increased that bell curve, if you want to think about it, as to high skill execution. So now you've still got to be an elite golfer to win PGA Tours, but there's much more people on lower handicaps these days because of this equipment advance, and not generally because everyone's just got better at golf. Anyway, I'll go through the two examples, swimsuits and golf balls now. All right, so going through our equipment advance examples, we've got swimsuits and golf balls. On this side, we'll cover swimsuits. All of these notes, once again, are much more in depth in your class notes, so make sure you read through them. So swimsuits, first of all, they moved from basically Speedos for boys and a one-piece for girls in the early 2000s to full-body suits, okay? Full-body suits, much like a wetsuit, but not spongy, just thin, with a shark skin type of material on the outside, which therefore ultimately reduced drag in the water, okay? Now, if you remember back from your Year 11 biomechanics stuff, which you probably don't, we know that drag is one of the fluid mechanics in that it will slow objects or people down as they travel through fluid, being water or air, okay? These suits in the water, they reduce drag, therefore enabled the athlete to move faster through the water without them having to change anything about their technique or their skill or their execution, okay? You simply just put the suit on, you swam, and all of a sudden you've got PBs, okay? So that's good, all right? I mean, And the good thing about these suits is that, at the time they were expensive, but nowadays everybody's got one, all right? So they're okay. However, in 2009, this is the big thing about swimsuits. Suits also, not only alongside the sharkskin material, but they had basically a spongy, foamy type property about them, which was really thin. It wasn't thick like a wetsuit, but it was effective enough that it increased buoyancy, all right? And by increasing buoyancy, so if you remember buoyancy being flotation, all right? So if you've got an athlete and they sit generally halfway in the water, right? They've got their back and their bottom outside of the water and everything else is in the water. These suits increase buoyancy, and it was only to the extent of an inch maybe, which isn't much, all right? But by getting the athlete outside of the water more and into the air more, and hopefully that water is thicker than air, they're able to move much, much faster over distance, to the point where in 2009 at the Swimming World Championships, 46 world records were broken. That's nuts. I think at the Olympics just gone, there was only 4 or 5 world records broken across the whole games, all of the events and everything. In this one event, because of these suits, 46 world records that have stood for years and years and years were broken, all right? So they were then coined super suits. And this is where the ethical problem comes in, right? Super suits were not available to all athletes and all teams, all right? 1, they were expensive, okay? But 2, most athletes and most teams are tied via contracts and sponsorships to certain people. So for example, I'm not sure, I think Australia might be with Arena, and USA might be with Adidas and whatever, okay? So all of those athletes in that team have to wear that company's stuff, all right? Now, when the super suits came out, there was only like four companies that produced them, all right? And across the 4 companies that produce them, and there's like multiple companies that do swimming gear, right? But out of the 4 companies, Adidas had the best suit, right? So if you weren't one of these 4, you had absolutely no hope of like even placing, let alone world record stuff. But if you were one of these 4, well, hopefully you were Adidas because they had the best suit, the best super suit, all right? It therefore was unethical, okay? Because the winner of swimming was no longer determined by their skill. It wasn't determined by their hard work and preparation, all that kind of stuff. It was simply determined by the brand that they wore, okay? So you might be thinking, oh, well, that's fine. We'll just give everyone the suit and therefore it's no longer an ethical problem. I mean, that's true. But remember, companies still have contracts and sponsorships, so you can't just give everyone an Adidas suit because that's going to make all the other swimming brand and companies out of business, which is no good. So therefore, FINA, the overarching governing body of swimming, decided the only fair thing that they could do was simply ban the buoyancy properties in suits from then on and going forward. Okay, so nowadays you look at the Olympics just gone, athletes are back to wearing, and since 2009, they have been back to wearing full body suits still. The material on the outside is allowed to change, but it needs a certain requirement of like thickness or thinness, I should say, to the point where there is no buoyant properties in that suit. So that's swimsuits. And the second one we've got is golf balls, all right? So there used to be 2 types of golf balls, and at the start of every hole you could pick your golf ball, okay? You could have a high spin ball or you could have a distance ball, all right? Now high spin balls were good for courses that basically had lots of left and right curves around it, because if you did need to do a draw or a fade, which is basically an intentional hook or slice, a high spin ball would enable you to get greater control on that draw and fade. The second type of ball was a distance ball, okay? So it basically minimized draw and fade, but it traveled a lot further. So very good on like long, straight holes, okay? But research, obviously, being smart little cookies, have now combined the benefits of both of those things into one ball. So now you can get a ball that travels far and you can still draw and fade it just as easily, all right? And then since then, so this all happened about 20 years ago, and then since then they've constantly been improving on greater speed and distance in the golf ball core itself. So if you hit a ball now, it's more likely to travel further. So golf balls, as I just said, now travel further, are less likely to hook and slice, and are easier to control, okay? Ethically, while golf balls are much more accessible than now, the swimsuits, like these swimsuits were like thousands and thousands of dollars, you can go pick up like a pack of top quality golf balls for $100, if that. So while golf balls are much more accessible, they're still bound by the whole sponsorship contract thing, because different golfers are sponsored by certain companies, Titleist. What's another golf company? I want to say Spalding. I mean, they're not really a golf company, but they do golf stuff. What's another one? Ping, there you go. Titleist, Ping, etc. Right? So while golf balls are much more accessible, they're still bound by sponsorships, and they also have reduced the original skill level that golf was intended to require. So what I mean by that is that the same as swimmers, over the years, like golfers generally haven't gotten better, as in like their technique's still the same. Like an immaculate golf swing today is the picture representation of an immaculate golf swing 20 years ago. But those 2 individuals, so let's go back to my identical twins, but this time we've got identical twins and they're born 20 years apart. I know, it doesn't work that way, whatever. Same golf swing, same genetics, and this time let's say they've got the same training innovations, all right? So they train the same way, everything they do is the same, except one guy uses equipment from 20 years ago and one guy uses equipment these days. This guy's gonna smash this guy, all right? Nothing else is different about the way they perform. It's just simply using a different golf ball, and I did mention golf clubs earlier as well. Using those 2 things, this guy will be able to reduce his swing count as opposed to this guy, by 6, 7, 8 across a course, which is a lot. So yeah, that's golf balls. That's golf balls, that's swimsuits, that was equipment advances. And that is the end of our video on use of technology. Thanks, bye.